This is the boost converter or step up converter as some of you may call it, which is based on XRS SEMI XL6009 chip, which is switching circuit and switching MOSFET in the one package. It can boost the input as low as 3 volt and can give output of more than 30 volts, and it claims that it can handle up to 4 amps of current at input. Current ratings at boost converters are always tricky, so stick with me and I will make it clear in a minute. So because of its advertised specifications, it is the first obvious choice for any project where you need to operate devices that run at higher voltages from a power supply of lower voltage. For a similar purpose, I purchased 3 pieces of these, and while I was testing them, I found a major issue with the boost converter. And the issue is that the chip itself gets very hot. Not the diode, not the inductor, but the chip itself. To have some quantitative analysis of the module and to find the cause, I attached an LED which works at 12 volt, and I am powering it with the help of the boost converter, to which I am supplying 5 volt. Let me cover up the LED so that we can see the boost converter. And very sorry that I cannot visually show you, but the chip has got very hot only after a few minutes of use. I can barely touch it with my finger, and it immediately tries to burn my finger as soon as I try touching it. And here some of you may say, hey Nishal, you are just overloading the chip and that's why it is getting hot. But if you think so, I am going to prove you wrong here. From the reading of my multimeter, you can clearly know that the input voltage for my boost converter is 5.02 volt, and the boost converter is giving approx 10.6 volt at the output, which seems fine at the first glance. But now let's see their current rating. I am putting my multimeter into current measurement mode, and now I will connect the boost converter in series with my multimeter. And as you can see, it is drawing around 1.34, 1.36, 1.37, okay, approx 1.36 amp of current. And guys, note here, it is rated for 4 amps at the input, and my input current is well below its advertised current rating. But still, it is getting extremely hot. So let's see its output current flow now. I will also disconnect one wire of the LED and again make in series with my multimeter. And after measuring the current at the output, which is 166 milliamp or 0.16 amp, which also seems fine. This has already made me very clear that why it is getting this hot. Let me use my whiteboard to show you this. As our input voltage was 5.02 volt and current consumption was 1.37 amp, our input power turns out to be 6.88 watt. And also because the output voltage was 10.46 at 0.17 amp of current consumption, which equals to only 1.78 watt of output power. And I think most of you have already guessed what is the problem. Output power is way less than the input power, and if you subtract the output power from the input power, it turns out to be that 5.1 watt of power is wasted as heat. And if we calculate its efficiency by the formula in output power divided by input power into 100, then it comes out 25.87%, which is very low. This is the reason that the chip was getting extremely hot, and all that remaining 74.12 or 74.13% of energy is all wasted in the chip, resulting the heat. Now let's talk about one more thing. All boost converters are rated at some current level like 2 amp, 3 amp, 4 amp or 6 amp. All this means is, let me make you clear with the example. If you have a boost converter rated at 4 amp and if you power it with the input voltage of 5 volt, then the maximum power output that you can expect from this boost converter, input current into input voltage times the conversion efficiency of that boost converter. Then you can only draw 1.33 amp at 12 volt, assuming that your boost converter has 80% conversion efficiency and your input power supply was 5 volt. So this problem was not only with a single boost converter, but with all other boost converters that I had purchased from the same seller, from this site, and all of them had the exact same issue. I have written a complaint letter, hope they will respond you back. I hope this has made something clear and something to note before using a boost converter while using in a project. If you like this video, then please don't forget to leave a thumbs up on this video, and please do consider subscribing this channel. See you in the next one. Bye bye.